For our lab 6, examples 1 and 2, we're gonna use a push button that's gonna turn on the onboard LED in Arduino, which is pin 13. Now you may notice here that since I'm using my adapter, we cannot see the onboard LED. So I'm just attaching an LED to pin 13. But if you try it, just like this schematic, you'll see this LED right here turning on. So we're gonna use first an interrupt. When we press the button to turn on and turn off the blue LED, then we're gonna use our real-time operating system. We're gonna use FreeRTOS to make a task that will turn on the button with an interrupt. So let's first test it, or to see the difference between an interrupt and looping. We're just gonna set up in loop mode. So let's define our button. So in my case, my button is connected to pin number 2. That's connected to my button. So let's define button as pin number 2. Now let's define our LED as pin number 13. Sorry. Now pin mode. Let's make it input. So my button's gonna be an input. And let's make our LED an output. Okay. And if digital read, that means that we're gonna check if we're pressing the button, right? It's equal to high. Let's toggle our LED. So for that, we're gonna use a boolean toggle. Let's make bool toggle. Let's make it 0 first. So what we're gonna do here is that we done this before in other labs. Digital right, and then let's take the LED equal. Let's do that LED toggle XOR with a 1. So what this one is gonna make is that since it's 0 first, 0 XOR with 1, it's just gonna be 1. Then this one XOR again with 1 is gonna be 0. The next time it's gonna be 1 and 0 and so far. And to avoid the debounce effect, we need to make a delay. I like to use 300 milliseconds, so we're just gonna keep that. And now let's load it. I forgot digital read. Button was not declared. Oh, I forgot a U here. Okay, good. And toggle. 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 There you go. So now if I press a button, it's turning on and turning off. But one problem here is that if I keep the button pressed, it's gonna keep high, because when I press it, I'm sending a 1. So if I keep my button pressed, as you see, well, I'm not releasing it, it's reading it more than once. The difference with the interrupt is that if I make an interrupt, it will just activate at that moment and only that one. So right now I'm just keep pressing it and it's still blinking. I release it and it stops. But if I keep the button pressed, it's gonna keep blinking, because in the loop it's constantly checking if I'm pressing the button or not. So right here is just checking. Since it's pressed, it's just XORing, going between 0 and 1. In an interrupt, it's a best approximation if you want to activate only once. So let's add the interrupt. As we saw in the notes, the way to do the interrupt, it's attach interrupt with a pin number, which can be 2 or 3. That's the only two ones that we can use in our Arduino. The name, GPIO, ISR, and the condition. We can go rising, falling, change, and low. So when I'm pressing the button, I'm going to rise. Right here we're at 0. I press it and we go from 0 to 1. So it's gonna be a rising condition. So let's attach that one here. Attach interrupt, and we can get rid of this button input because it's not going to be an input, it's going to be an interrupt. So attach interrupt, and then digital pin to interrupt pin number 2, right? That's the one that we're using for our schematic. Then if we want to go GPIO ISR, that's the name, GPIO ISR. And finally, if we want to go falling, rising, change, or low. So let's go rising. Okay, good. Now we need to make a function with this name. So the code's gonna be looping around. And then when I press the button and it changes from 0 to 1, it'll jump here. So let's erase all this. And what we're gonna do is we're going here to the interrupt, and what we want to do is to tell the user that the interrupt has been activated. So we're gonna use a semaphore. Let's make a semaphore, which is gonna be like a flag, equals 0. So when we press the button and we jump to the interrupt, we're gonna make our semaphore equal to 1. And in my code, in my loop, what I'm gonna do is just check if semaphore is equal to 1 as long as I press the button, right? I make this signal a 1. So we're gonna do our toggle here. Digital right LED toggle XOR 1, and we're gonna make a delay for the debounce effect, 300 milliseconds, and let's erase our semaphore so that it's just gonna be 0 once. So the code's gonna be checking, but since semaphore is equal to 0, it won't enter. When we press a button, it's gonna make semaphore equal to 1. It's gonna get out of the interrupt, go back here. Since my semaphore is 1 when I press a button, it's gonna toggle my LED, wait 300 milliseconds to avoid the bounce effect, and then it's gonna reset the semaphore signal so that it doesn't go inside again. Let's give it a try, see how it works. Okay, so right now it's at 0. Let's press it once, and you can see it's turning on. Even though I keep my button pressed, it won't do it just because the way that the interrupt works. I release it and it's not even changing because it will only change with a rising condition. That means that we'll go from 0 to 1. At this point, the interrupt gets activated. If you want to activate the interrupt, when I release the button, we need to change this rising for falling. In that case, I'm at 0, I press it, and when I release it, it activates it. So that's the bouncing effect. Let me see if I can. There you go. So right now it's a 0. It's a 1. Sorry, I'm pressing it. I'm at level 1. I'm gonna release it, and it's gonna activate the interrupt. And that's how Lab 6 example 1 works. Now let's make it a little bit more interesting. Let's include our FreeRTOS library. So let's make a real-time operating system example of this. So now we're moving to lab 6 example 2. So include Arduino FreeRTOS.h, and now let's include the semaphore library. So instead of making these Boolean semaphores, we're gonna use a proper library to make our semaphores. These two libraries are going to be included once you install the FreeRTOS library that you can find in Blackboard. So make sure that you install this first before testing this example code. So now, instead of doing our semaphore in Boolean like this, we're gonna use a class semaphore or the data type. So semaphore handle underscore t. Make sure that it goes orange. That means that it's correct. It's you wrote it properly. Button semaphore. It's just a name. That name can be whatever you want to call it. So in my case, I'm calling it button semaphore. Now let's do just our toggle here, so I can get rid of this, right? And in my setup, I need to do my pin mode, which I have right here, and we need to make a task. So we're gonna create a task here. The task is gonna be the task function that will be running in my RTOS. So it's x task create. Needs to turn orange. That means that you're writing it right. Task LED. It's because that's the name that I want to use in my function. You can call it whatever you want. And this is from this example right here. In this case, I call it alarm. Now I'm calling it task LED. The next thing that we need to do is the name of the function in string format. So this is just LED. Then we need to define our stack size. Something that you can do is you can just put everything in just one line. You can do it like this. It's just that I'm used to write it in this way because when you make usually tasks, it's easier to find out parameters in this way. But you can do it in just one line. Note for parameters, we're not setting anything. Priority 0. It's the only task, but it's just gonna give it the highest priority. So level 0, and finally null, which is the handle pass. So just keep those null like that. Don't worry about them. We're not using them for simplicity. And that's it for a task. Now, just make sure that when you make your function, it has this task name. So if I make my function here below, I need to make that same name. Let's say that I put it here below my semaphore, and we're not receiving anything, so just put void, and let's just do void and PV parameters. You have to write it like this. It's just make the name and make sure that you write it like with this syntax. Okay, and we're just ignoring our parameters, so good. If I go here in my loop, now I can have this one empty. So what's going to happen with a real-time operating system is that the loop's going to be empty, and every certain time it's going to jump here, execute this task, and then go back to the loop. If you have more than one task, it's going to do one task with its own timer, and then it's going to move on to the other task, and then go to the previous task and move on. So even though you can see here that my void loop it's empty, it will be doing tasks. So what type of task do I want to do? Well, in my task, what I want to do is to turn on the light, do the toggle. So first, in my I forgot to declare the semaphore. So here, let's declare the semaphore. But semaphore equal to x semaphore create binary. So it's the same thing as saying, okay, it's gonna be Boolean. It'll be just 1 and 0. So it's just a function that will assign my semaphore to a Boolean semaphore. So we'll go between 0 and 1, 0 and 1. Now, when I press the button, what I want to do, instead of make my semaphore equal to 1, I want to give my semaphore. That means that I'm allowing any other user to take the semaphore. So I'm giving it. That means that when I press a button, I'm releasing the semaphore so that the task here can use that semaphore. Remember the example, like when you want to use like different recursors, the semaphore, let's say this car wants to use a traffic light, so it uses it, and when it gives it, it's letting any other car to take the traffic light or the route to go between cars. So yeah, take control over whatever action you want to do. So let's do that here. If I press a button, I'm gonna give the semaphore. So x semaphore get from ISR. So we're releasing it, and we're releasing a semaphore. Give me 1 second, because it's supposed to be orange. X semaphore get from ISR. Okay. Button semaphore, which is the name of the semaphore that we're using here. No. Okay, good. Semaphore, oh, right here. Semaphore. Good. Should be orange. And when I press a button, I'm releasing the semaphore so that my task can take the semaphore for a specific amount of time and play with it. So let's make our task to check if I can take my semaphore, if x semaphore. Oh, let's put all of this inside of a while loop. So we're going to be using a while one here. If x semaphore take, that means that, okay, I'm going to try to see if I can take the semaphore. Which semaphore? The one that the ISR is releasing, and actually it's the only semaphore that we have here. So we're gonna check if we can take the semaphore. If we can check it, if we can take it, we're gonna take it for 300 milliseconds, which is 500 3 3 3 3 3 2. That's just dividing the clock frequency by this number, and it's going to be equal to 300 milliseconds, which is just divide 16 million over this number, and it should give you 300 milliseconds. Keep in mind that the frequency is 16 megahertz. So, well, actually, if you divide this by 6 million, you're going to end up with 0.3. Which is 300 milliseconds, right? 0.3 seconds, is 300 milliseconds. So that's equal to PD pass. And let's turn on or toggle, sorry, our LED. Good. So LED, oh, digital right. Up this one a little bit. There you go. Digital right. LED toggle X or 1. So what we're doing here is that we press the button, right? The interrupt button. The code is here playing between the loop and the task, but since I cannot take the semaphore, it's just gonna skip it, right? So when I press the button, I give the semaphore so that anyone can use it. So it's gonna get out of there with the semaphore released. Then when it goes through this line, it's gonna check, okay, can I take the semaphore? Since it's been released, it's gonna take it for 300 milliseconds only. So that's the amount of time that we can use the semaphore. After it takes it, it's gonna go here to digital right, and it's gonna toggle my LED light. So let's see if it works. Forgetting something here. PV pass. Oh, it's supposed to be capital A. Look at this. It's a global variable. There you go. Good. Let's see. And yeah, it's working. So it must be activating it more than once because of the bouncing effect. Yeah, that's the bouncing effect. But we can count the times that it's entering here just to make sure. So like make a count variable and count equal to 0. Then let's go here, and every time that I go here, let's do count plus plus. It just increment it by 1, and let's show it with our serial console. So serial that println, and we're gonna show our count. And don't forget to initialize our serial console. Serial that begin. Let's do standard baud rate 9600. Okay, good. Let's see if it works. So I press it once, it's taking it once, I'm releasing it, and it's counting 2 and 3. Again, that's the debounce effect. It's normal. The way to avoid it is making a delay, but in our interrupts, we cannot use delays. That will not work here. So if I try to use a delay inside of a task, it won't work. But with a B-task delay, we may fix it. But I'm gonna do that in the next lab example. So that's it for your lab example 1 and 2.